As with most of these more difficult concepts, you have to establish rules. Now, I hit you without introducing the rules with the first part of it, because I found out over the years that it piques the student's interest if you go through an example and quote the rule, but do not explain it entirely. Thus, afterwards, you come back and you quote the rules. And here are the rules. Number one, atoms by themselves have an oxidation number of 0. Acceptable. Number two, oxidation state for monatomic ions, same as a charge in the monatomic ions. And the examples I've got there are kind of hard to see a little bit. But you have sodium, column 1 elements is a +1, and chlorine, which is in column 7, is a -1. So if that's hard to see, I clarified. Sodium again, +1, chlorine, -1. 3, oxygen is 2-, and covalent compounds except peroxide. Remember, peroxide is the only exception to oxygen being 2-. Thus, in CO2 or CO2-, oxygen is 2-, carbon's 2+, CO3 2-. You got 6 negatives with the oxygen, but 2 accounted for with the charge. So in that instance, oxygen is 2- per atom. And that makes the carbon 4+ in that one. And then we have our exception to the rule, the peroxide, H2O2, hydrogen peroxide, used for a variety of things from bleaching to bacterial removal and that sort of thing, is H2O2. In that instance, oxygen is a -1. All right, as we continue, number 4, covalent compounds, hydrogen is a +1, as in NH3, which is ammonia. It is a +1. And water, of course, H2O, which we've already covered ad nauseum. Hydrogen's +1, 2 of them, +2, and oxygen is a -2, giving you a neutral compound, water. Number 5, fluorine is always -1. Now, that should be kind of something that sticks in your craw because it's the only exception. Fluorine is always -1. 6, sum, or the added, of the oxidation states must always equal 0. As I indicated in the illustration at the first of this, with the example, the 8 electrons on the oxidation side have to balance out with the 8 electrons on the reduction side. So neutral compounds such as water have that, as I've illustrated previously. And polyatomic ions, you add up equal to the charge of the ion itself. Now, CO3 is a 2- charge, so we say its oxidation number is a -2 or 2-. Ammonium, NH4 +1, is said to have an oxidation number of a +1, or its oxidation is +1.